Welcome to another episode of C Sharp Tutorial for Beginners. This is part 5 of C Sharp Tutorial. In this course, C Sharp.NET programming basics are covered. I hope you are enjoying this fast-paced C Sharp training. I have tried my best to keep it to the point, concise and easy to understand. This video is about LINQ in C Sharp. LINQ is a very important topic in C Sharp programming. First, we will learn what is LINQ and what problems it solves, and what are LINQ providers. Then we will learn about syntax of LINQ. As we go, we will build query expressions and use query operators. We will use different classes of LINQ to write effective queries like joins and groups. LINQ stands for Language Integrated Query Language. It is built into .NET Framework. It is used to query data. It is type safe and provides IntelliSense. It catches errors at compile time. Traditionally, queries against data are expressed as simple strings without type checking at compile time or IntelliSense support. So the first problem it solves is the type safety. The second advantage is that the same language works with multiple types of data sources. You do not have to learn a different query language for each type of data source. Using LINQ, you can query SQL databases, XML documents, various web services, ADO.NET datasets, and so on. With LINQ, a query is a first-class language construct, just like classes, methods, and events. You write queries against strongly typed collections of objects by using language keywords and familiar operators. The LINQ provides a consistent query experience for objects, linked to objects, relational databases, and XML. Please note, LINQ only works with enumerable types such as arrays, collections, and lists. These are the types which implement generic or non-generic enumerable interfaces. In LINQ, these enumerable types are also referred as sequences. The query syntax is declarative. By using query syntax, you can perform filtering, ordering, and grouping operations on data sources with a minimum of code. You can use the same basic query patterns to query and transform data in SQL databases, ADO.NET datasets, XML documents and streams, and .NET collections. The query syntax is similar to SQL. It has more or less same kind of classes, functions, and operations. So if you know SQL, LINQ will be easy for you. What is LINQ provider? These are modules that implement LINQ queries in terms of data source. For example, LINQ to SQL provider translates the LINQ queries to their equivalent SQL statements for SQL Server. There are several data providers written by Microsoft. For example, LINQ to SQL, LINQ to XML, LINQ to dataset, LINQ to entities, and LINQ to objects, and many others are available from third parties. Here is an example where a LINQ query is written to query an array. Here, an array of integers is declared. Name of the array is scores. And here, a variable score query is declared to hold query expression. The type of the variable is enumerable of int, and query is assigned to it. This is how a query is declared. From score in scores, where score greater than 80, select score. So this query expression looks like an SQL statement. It has a from class, a where class, and a select class. Then using a for each loop, the result is printed. Please note the query is not executed until it is accessed in the loop. If you see the customer class, it has 4 properties. But the LINQ query is returning only 2 properties. In this case, C# is creating a new class in the background with only 2 attributes. And then it creates objects of this class, assigns values from the cust object to the new object, and returns a collection of its objects. This newly created class is known as anonymous type. So anonymous type is another important feature in C#, which is widely used in LINQ queries. Anonymous type is a type which is created without explicit declaration. An object is created using the new keyword and then values are assigned to its properties. The type is created at compile time and types of properties are inferred from the object. A name of the type is generated by the compiler, but it is not available in the source code. The type is value type and all its properties are public read-only properties. Here is another example. In this example, an object myObj is created using var keyword. Var keyword must be used because we do not know the name of the class. And then new keyword is written after the assignment operator. And then in a pair of curly brackets, properties are included separated by commas. Name of the first property is age and a value 30 is assigned to it. The second property is name and it is a local variable in main method. Value and type of this variable is taken from the local variable definition. So you can include local variables in anonymous objects creation. Similarly, the third property is myProperty and it is defined as static property in another class. So you can include properties of other objects or static properties in an anonymous type. You can also create an array of anonymous objects. But the anonymous objects are most often created and used in LINQ queries. Here is another example, which explains the most common scenario used in LINQ. It initializes an anonymous type with properties from another type. This example assumes that a class named product exists, and it includes color and price properties, together with other properties that you are not interested in. Variable products is a collection of product objects. In the select class, the anonymous type declaration starts with the new keyword. The declaration initializes the new type that uses only two properties from the product. If you do not specify member names in the anonymous type, the compiler gives the same name as the property being used to initialize them. In this example, names of the properties of the anonymous type are color and price. LINQ provides two types of syntax to write LINQ queries. The first syntax is query syntax and the second syntax is method syntax. The query syntax is in declarative form and it describes what to do and does not specify how to do. C# figures out how to perform the query. It is more readable and easy to understand. It is written as query expression. It looks similar to SQL statements. Therefore, it is the most preferred syntax. The second type of syntax is method syntax. Method syntax uses standard method invocations. The method calls invoke the standard query operators, which have names such as where, select, group by, join, max, and average. You can call them directly by using method syntax instead of query syntax. Method syntax is an imperative form, which specifies an exact order in which query methods are to be called. The query syntax is also translated by C# compiler internally into the method invocation form. Therefore, there is no difference in runtime performance between the two forms. And you can also combine query syntax and method syntax. And it should only be done when there is no alternative available in the query syntax. For example, aggregate functions like count, average are used directly in query syntax. Here is another point to remember about the return type of the query. A query can either return an enumerable collection or a scalar value. When the return type is enumerable, the query is not executed until it is iterated. Here, the compiler just creates the code that will be executed when the query is run, if it is called upon to do so later in the code. This is called deferred execution. But if the return type of the query is scalar, the query is executed immediately. Here in this example, a query variable myQuery is declared. The return type of myQuery is IEnumerable of int. It is executed when it is accessed here in the for each loop. If I access the variable in another loop, it will be executed again. But here is the second query, which returns a scalar value. This is executed immediately. It is not a deferred query. And the result is immediately available in the variable count. There are some methods which return scalar values. We will discuss these methods later. So in summary, If a query expression returns an enumeration, the query is not executed until the enumeration is processed. If the enumeration is processed multiple times, the query is executed multiple times. If the data changes between the time the enumeration is produced and the time the query is executed, the query is run on the new data. If the query expression returns a scalar, the query is executed immediately and the result is stored in the query variable. Let us understand LINQ query structure. There are several classes in a LINQ. A LINQ query must begin with from class and must end with select or group class. All other classes are optional. The from clause is used to specify data sources or sequences. Where clause is used to filter source elements. Select clause is used to specify the properties which are to be produced in the output. And group clause is used to group records. Into clause is used to provide a name or identifier to the result set for further reference. Order by clause is used to sort the query results. Join clause is used to perform join operations. And let clause allows to introduce a range variable to hold results of a sub-expression. A query expression must begin with the from clause. Additionally, each subquery also begins with the from clause. After the from keyword, name of the local range variable is written. That represents each element in the source sequence or collection. In this case, it is num. And then, after the in keyword, name of data source is written. The type of the range variable is inferred if the data source implements generic I enumerable of t. Otherwise, the type must be specified if it implements non-generic I enumerable. Here in this case, type needs not to be specified. Here, I have changed the data source from array to array list. I have also specified data type of the range variable, which is int. It is because array list implements non-generic I enumerable. Here, I have changed the data source from array to array list. I have also specified data type of the range variable, which is int. The range variable looks like an iteration variable in a for each loop statement, except for one very important difference. A range variable never actually stores data from the source. It's just syntactic convenience that enables the query to describe what will occur when the query is executed. In some scenarios, you will write the from clause more than once to specify multiple data sources. Here in this example, students list contains student objects, and each student object also contains an inner list of scores. So in this case, from clause is used twice. The where clause is used in a query expression to specify which elements from the data source will be returned in the query expression. It applies a Boolean condition to each source element, referenced by the range variable, and returns those for which the specified condition is true. A single query expression may contain multiple where clauses, and a single clause may contain multiple conditions. The where clause can be positioned almost anywhere in a query expression, except it cannot be the first or last clause. A where clause may appear either before or after the group clause, depending on whether you have to filter the source elements before or after they are grouped. In a query expression, the select clause specifies the type of values that will be produced when the query is executed. The result is based on the evaluation of all the previous clauses and on any expressions in the select clause itself. A query expression must terminate with either a select clause or a group clause. The group clause returns a sequence of I grouping objects that contain 0 or more items that match the key value for the group. Here is an example of the group clause to group student objects by last name. Name of the range variable is mentioned after the group clause and name of the key is mentioned after the by clause. Under each key, the collection of the related students will be set as a value. Note that select clause is not used in this query. The group class by default returns an object of I groupings, and there is no need for select class. You can name the group by using into class if it needs to be referenced in the query. Here I have referenced the group name in the ORDERBY class, ORDERBY grp.key, but this violates another condition. Every query must end with group class or select class. So I have written the select statement to satisfy the condition. Here I have written the loops. The outer loops iterates through the group and prints its key or other aggregates like count. The inner loop iterates through student collection within each group. Group key can be a number, string, boolean or anonymous type. Here in this example, an anonymous type is used as composite key. You can use where clause after the group to exclude groups which do not meet the condition. This where clause will exclude the groups which have 1 or 0 student records. So it works like having clause in SQL. If where clause is used before the group clause, it works on object level before including it in the group. You must understand this difference. The into keyword is used to create a temporary identifier to store the results of group, join, or select clauses into a new identifier. This identifier can itself be a generator for additional query commands. When used in a group or select class, the use of the new identifier is sometimes referred as continuation. Order by clause is used to sort the results. You can specify comma delimited list of properties. To sort in ascending or descending order, append ascending or descending keyword after the property name. Use of ascending or descending keyword is optional. By default, it is ascending order. The let keyword is used to store the results of a sub-expression in order to use it in subsequent clauses. The let keyword creates a new range variable and initializes it with the result of the expression. Once initialized with a value, the range variable cannot be used to store another value. However, if the range variable holds a queryable type, it can be queried. Here in this example, an expression is assigned to a variable valid, and then the variable valid is used in where clause. The join clause. The join clause is used to associate elements from two sequences or data sources that have no direct relationship in the object model. The elements in each sequence must either be or contain a property that can be compared to a corresponding property in the other sequence. The join clause compares the specified keys for equality by using the special equals keyword. All joins performed by the join clause are equijoins. The shape of the output of a join clause depends on the specific type of join you are performing. The following are three most common join types: inner join, group join, left outer join. In a LINQ query expression, join operations are performed on object collections. Object collections cannot be joined in exactly the same way as two relational tables. In LINQ, explicit join clauses are only required when two source sequences are not tied by any relationship. When working with LINQ to SQL, foreign key tables are represented in the object model as properties of the primary table. Here is an example of inner equijoin. Name of the first sequence is mentioned in the from clause, and name of the second sequence is mentioned in the join clause. And then after the join clause, on clause is mentioned. The on clause mentions the names of the fields from both the sequences, which are compared using equals keyword. The on clause specifies the relationship between the two sequences. Note that equals is the only keyword which can be used to compare two properties or objects in the on clause. You cannot use equality operator or any other condition. Only equijoin is supported. This point needs to be remembered. And then select statement is used to create an anonymous object with fields from both the sequences. This query produces a flat sequence of product name category pairs. The same category string will appear in multiple elements. If an element from the categories has no matching products, that category will not appear in the results. Here after the on clause, into keyword clause is written and then prod group is written. This is called group join and it has no equivalent in SQL. It produces hierarchical result. It picks all of the category objects and makes them root nodes. Then under each root node, it creates a collection named prod group and adds all the related products in it. The select command is used to produce new anonymous objects. Note, prod group collection is assigned to products property. You will need two loops to iterate through the result. The outer loop iterates through the categories, and the inner loop iterates through the products under each category. If you see the cat3, it has an empty product list, but it is still included in the result. So you can say it is kind of left outer join, but it is in hierarchical form. However, we can produce a flat anonymous object to mimic the left outer join in SQL. To achieve this, an additional from clause is added. This from clause iterates over the group, and if prod group is empty, it creates a default empty item and returns it. And lastly, the select clause produces the result. You cannot compare more than one key using on clause. However, you can achieve this by creating anonymous objects for composite keys and use them. Here an anonymous object is created on the left side of equals keyword. And also similar object is created on the right side of equals keyword. Join clause only supports equijoins. Non-equijoins are not supported. The join clause does not allow to specify compound conditions. However, you can achieve this without using the join clause. For example, here I have written an example of cross join without using the join clause. Note that two from clauses are used, one for each sequence, and then a new object is produced which joins the two objects. Now let us learn about standard query operators. The standard query operators are methods used in method syntax. These are defined as extension methods. In fact, the LINQ query syntax is translated to these method calls in background. Some methods return enumerables or other sequences, whereas other methods return scalar values. Scalar methods cause immediate execution of the query. Similarly, methods like toList, toArray, toDictionary, toLookup also cause immediate execution. Many methods accept a predicate or delegate as a parameter. A predicate is a method that takes an object as parameter and returns true or false. It means you can provide a custom logic to the operator. You can also write your own custom operators or provide your own implementations and query translations. Here are some examples which will make your understanding better. Here at this line, count operator is applied on a query. It causes the query to execute immediately and return the result to count one variable. And on the next line, count operator is directly applied on the array. This explains that you can apply any operator directly on a sequence. On next line, a lambda expression is passed to the count operator, which returns true if the number is even. So in this case, count method only counts the even numbers. The next example explains how a delegate is passed to the count operator. A delegate object mydel of generic func delegate is created and reference of a method isOdd is added to it. So this time the count operator only counts the odd numbers. Please note, delegates, enumerators, and iterators are important topics to understand. I have already uploaded videos on these topics. There are dozens of func action delegates already declared for using with LINQ. Okay, this topic ends here. Please start practicing these queries. Please ask questions in the comments section and let me know your feedback. Please subscribe to my channel for upcoming videos on C# and also like and share this video with your friends. Happy coding!